Alright, so if I recall correctly, we are on section 13.4 of Book of Monads. So let's get going, I guess. It's in here. I don't even remember. Yep, here we go. So now we're going to talk about operational style. We're going to talk about operational style in freer monads. So here we go. So it says initial style monads reify computations as a data type. Last, there's one important drawback. Initial style forces us to write constructors with awkward types, using continuations to keep track of successive computations. Operational style uses a data type to represent computations, but the shape mirrors much more closely the way we describe those computations using do notation or for comprehensions. So we're gonna keep going down this tic-tac-toe thing, but we're gonna talk about I guess operational style. Okay, so using a GADDT. So we need to get GADT. I don't think, well, we can just see if it starts working. So like, I don't know if any of these, I don't know if any of these language extensions imply GADTs. So we'll see if that's the case. So data, tic-tac-toe, where info, position, tic-tac-toe, maybe player, take, tic-tac-toe result. We're gonna have to define these, but done. And bind. To be some monadic operation. It looks exactly like bind from, the typical bind operation. Okay, let's just put a prime here. Okay, and then we need to go probably just get these definitions real quick, which should be in final layer. So position, result. And these types hold no value. Like, they're not probably what they should be. It's just to get this to compile. Like, we're not actually going to implement any of these things. So it's kind of just helping us make the compiler happy. Okay. Here we go. Some Scala code in here, but we're going to ignore it. We can provide a monad instance for this data type. Oh, and also note that this works and the compiler is not complaining as far as I can tell. It might be. It just says error. Oh, I see. Okay, so we need to final take. So it's not lib take, it's final. It's the one from this current library. Or module, sorry, not library. It's not the right term. Okay, so that should fix that error. And then now we're getting a GADT error probably. Yep, enable, see, it's right there. So we just add GADTs, and now we're good to go. So I noticed a few viewers hanging out, so hi, how's it going? Tell me about your day, if you want, you don't have to. Okay. Show. We got that. So we can define instance monad tic-tac-toe where return equals done and oh, right, okay, so we're gonna have to do so one problem with this, which I can already see, is right, we need actually fmap. What's up, Versus? How's it going? I don't know if I've seen you before. Not 100% sure. I feel like I have, but fortunately I can't remember everybody. Not bad is good. So like, we need like a function like this, right? Oh, nice. Yeah, okay. I was like, I thought I did, but it's hard to say. Again, there's a lot of people. Oh, right. We need to embed this probably. So it's probably like tic-tac-toe A, tic-tac-toe B. And then what we would also need like apply. What's up, Warren? Anybody do any interesting Haskell today? Or Elm or PureScript or whatever? Whatever code you felt like writing today? So I guess we would do like functor. Nice. Nix, did some PureScript. That's good. So I made a decision today. So I want to write. I don't know if any of you were here on Sunday. I think Oren was, but I decided I'm writing like a comparison between the database libraries in Haskell, the type-safe ones particularly, and like I'm already working on a presentation for that. But I decided I want to do something similar for Elm, PureScript, Miso, and Reflex. So I think that's going to be one of our next little side projects, is writing some comparisons with like full examples with pros, cons, kind of like everything together. Yeah, that's what I want to do, because I have this really bad problem of not being able to make like decisions about what to use. So the only way you can do that is like providing a technical document that ideally is as unopinionated as possible, objective, whatever you want to say, and just give it a shot. So that's what I'm going to try and do. I don't know if I can, but I'm going to try. What? Oh, right. I can't actually write that. Okay, we're close. I just have the definition backwards, like a doofus. Oops. So I think that's going to be one of the new things we do as side projects, like trying to write some technical comparisons. Exactly. So that's like yeah, I agree completely with you, Oren. That. Yeah, and that's like the other thing is like I want to put all this stuff in a GitHub repo so that people can like make comments on it, right? And tell me what I'm doing wrong, because I'm probably going to be doing stuff wrong. Yeah, I don't know. I don't know. So that's part of the reason why I want to do the comparison between like PureScript, Elm, and Miso and Reflex, is because I can't make a decision. I last week when we were doing Elm, actually Versus was there. I ran into an issue that was like really frustrating to me. Like I wanted to define a more interesting type, and I couldn't. And that bothered me. Like I didn't like that. So, it's kind of hard to figure out sometimes. So, this looks like apply, right? Oh, I keep doing it backwards. The F comes first. I'm such a doofus. My bad. Yeah. There you go. So I guess this is how you have to write this. Really liking using concur with PureScript right now. You have all the power of PureScript, but you can still use the Elm architecture if you want. Interesting. So the I forget who it was, but somebody suggested using halogen. That was the other one. So it's like now, if I want to like actually do all of them, I have to add all of the front end libraries in PureScript as well, and I think there's at least 3 or 4 of them. I've heard of, well, I know of Concur and what's the other one that I just said? Halogen. Those 2. So I don't know what to do. Okay, so this is operational style. So is the idea that these are free because you have to implement these? They're not. I mean, that's not free. You get to use the syntax by writing the functions. So I don't see exactly what I'm benefiting from here yet. But apparently the thermite. Okay. So like, here's another thing is like, look, here are 3 front-end PureScript libraries. Let's compare those. I feel like I could get a lot of mileage out of posts like that. Maybe we could draw in some viewers that way. And it would be useful for me, so. Taken. I shouldn't, like, the options, exactly. There's too many options, and it ruins me. Like, I get stuck. It's like, which one should I pick? I don't know. How do you find out? I don't know. Yeah. But then, like, we were like, well, I mean, everyone said this is like, okay, well, you can choose Elm because you have to make less decisions if you choose Elm. And then in 5 chapters of the book about Elm, I ran into an issue that I found to be like, pretty problematic. So it's like, I don't know what to do, man. So we can have these functions, by the way. I don't want to define these right now. So we'll just leave them undefined. But the idea is I want to write something like this. Info P. Case I of. That's an interesting thing to type. Yeah, yep. I was trying to define a key that was a custom sum type. And you can't do that. Oh, well, I guess it... I guess I need to put these here. Oh, I get it. I put this here, and then I can stick info and take here, I guess. Yeah. Okay. And then here we can write nothing. Take P. And in theory, this should compile. Right. Lib dot. All right, so I guess it depends on what your goals are. If you just want to build stuff and not worry too much about complexity, Elm is still a great option. While I do enjoy Elm, I like some of the theory that Haskell and PureScript bring. Yeah, I mean, the custom data type stuff is just really powerful, and the being able to define instances of things if you want to have your own custom types is like, that feels very fundamental to me now that I've been working with Haskell for a year and a half. So the fact that Elm takes that away from me makes it less appealing, and I didn't realize that was going to be like so quickly a problem. People that watch this are going to be we could have done lists, but it's like it's kind of a band-aid, right? Yeah, but we could just write we could have just written a class that was just like a list of tuples and created an interface around that if we wanted to. Yeah, I think, yeah. Anyway, so what I was saying before is anybody that comes to watch this for the Haskell piece is gonna be like, why are you talking about Elm like on YouTube? But I don't care. Do. All right, so why would I write the applicative instance in terms of the monad instance? Oh, right, because in GHC 7 they weren't connected, so I could use the monad instance to define the applicative. So like right now I'm writing the functor. Okay, so what it's asking me to do is write the functor and the applicative instance in terms of the monad. Okay, anyway. You know, the key. Yeah, like we could have done that as well. There's lots of options to do it that would have probably been better. But we ended up using essentially a custom record instead of using a dictionary. So, and it wasn't even really a custom record. We just added those records to our model. That's basically what we did at the end. Orin. This is confusing to me. I don't know what to think about this. Hang on. So the idea is that we're going to write you're chasing your baby. That's funny. Yeah. I mean, I wouldn't say it exactly like that, Pick, but I see where you're going anyway. So, one thing I don't understand is, can I define a functor in terms of its monad instance? Like, were those that separated when this book came out that I could just, like, use the monad instance to implement the functor? It seems to me like I shouldn't be able to write the functor in terms of the monad. Just very confused. Like, doesn't that defeat the purpose of having functor and applicative because I have to bind every time? Yeah, that's what they're doing here. So, well, they're not doing it for functor. They're asking me to implement it. But basically what they're doing is showing me the following. I'll show you. So let's comment this out. How do I do that again? No. GC, there we go. It is possible, okay? It seems like it completely defeats the purpose, but okay. So this is what they have in the book. Is the point of that just so you don't have to define all of these different instances? So let me comment these out as well. And we'll come back to this in a second. So pure equals done prime. F X whatever do and then we also need to define return. Oh wait, No, we don't, because we have pure defined. All right, so what's the problem here? Use fmap. Oh, we're gonna write f prime fmap x, I think. Is that right? Okay, I need to see this whole thing. Yeah, I'll have some tea. Oh, sorry. Use fmap. Okay, let's see what it's trying to tell me to do. Oh, sure. Right. I don't need return there because return would put this thing in another done. All right. So anyway, that's what the book gives me. So the thing I'm trying to understand is I thought the goal of this was to, or not the goal, that's not really the right way to say this. Like applicative is really nice because you don't have this problem of sequential computation, right? But don't we turn our computations into sequential ones when we write the apply as an instance of monad? And why can I do this in the first place if I don't require that this I guess it is implicitly also a monad because I've defined a monad instance. Yeah. Like applicative should have less power than the monad, but now it doesn't. Now it's the same thing. So why does that help me? I just don't know. I'm very confused. Okay, anyway. Um I don't know. I'm a little confused right now. Write the functor instance. It's pretty obvious that we're going to do that from now on. So we're going to have an F and an A. And I guess we're going to do this in do. So it's going to be do A prime A F map. No. F A prime pure. And that's the exact same as just... Wait, I can't do F map A? Isn't that cyclic dependency? Oh, I can just do... Right. No. How? How would this work? That can't work. I disagree, Linter. You've just turned this into a computation that would never finish. Okay, so we've now made functor and applicative not very special. They do not provide the benefits that functor and applicative give, I suppose. I don't know. I don't understand the point right now. Sorry. As is the case of initial style monads, interpretations do not require the target to be a monad. However, the most interesting semantics are actually natural transformations from the custom monad into another one. An interpretation that is parametric over the return type of the monad. Here's the operation style version of the run game interpretation we have already described in the other styles. Okay, let's look at that, I suppose. I'm a little lost again, which is not surprising. That happens to me all the time. So, like, we got a tic-tac-toe of A and a reader T, player, state T, board, IO, A. Bind XF. Run game dot F. We'll fix these other things in a second. I'm gonna keep writing. Yeah. Yep. Yeah, you're exactly right. Yep. Yep. A. Right, because this would be like the same thing. And then you could write pure FA. So this is what Oren was doing, right? And then we can make this point free because A is just passed along. So you can just get rid of this, make that a dot, and remove that A. That should have been an A prime, by the way. So, yep, that's pretty convenient. And you can do basically the exact same thing here if you wanted to, because you can just say F. Oh yeah, we could just do flip this and remove the A. And we could probably do even more stuff, but it would start to look kind of funky. So right, like this is this. What's up, active? And then this one would be, so if we wanted to remove A, we could say can you do that? That looks really weird. No, you can't possibly. Oh, wait. We would just do this, I think. Maybe we need parentheses. Can we not do this? I guess not. We would have to do... like that. And you can go even further. Sorry, let me do some, yeah, let me do some other stuff here. I want to do this stepwise so that we don't confuse people later, right? Right? Oops, wrong button. And then we could just do, okay, how do we get rid of that? Is it? Might be. You know how we get rid of this is we just go to point free IO and look at the result. And try to make sure we understand it. Yeah, that looks right. Similar. Well, that's good. Congratulations. And yeah, so what happened? Flip that thing. Well, return, I know what that thing is. And pure dot. Look at that. Why is it complain? It was like sort of complaining, but not. You could probably do the same thing here, but I just don't want to. Now I feel like I have to. Oren brought me down the write everything in point freestyle, and now I kind of want to keep going. So this one would be kapow. Well, that one's sweet. Where do you get kapow? You can just type kapow. That's pretty great. Nice. I didn't know about that one. I don't know how to remove this F. Let's see if it's even comprehensible. Wow. Right, because you're just putting .fmap on the right this time. Does that make sense? Yeah. It's always Blackbird. Very fun. Oh, yeah, so hang on. No, that's not gonna work. Oh, do 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 do. This is wild. Mm-hmm. Very fun. Very fun. It really wants to think about this. The compiler is very confused. Or not very confused, but it's clearly doing some more heavy lifting there because it doesn't like it. Anyway, that was a fun little point-free exercise. We can't get reader T, and we also need board, so let's go get those things. Board. I don't have board in here. Tic-tac-toe. Board. Board. Wait, don't I need to get map? Oh, I already have it, okay. Interesting. And then reader T comes from control transformer reader. Control monad trans, sorry. I feel like I haven't done actual like Haskell like this in a while. I'm out of practice already, which is absurd. Like I shouldn't have that kind of problem. Run game info the lookup. It's gonna be m dot lookup p get. Isn't that just info p? Oh, okay, I called it app, that's fine. Well, it would be run game info p, I suppose, but and then we have like an incomplete because the rest of the game logic would need to go there, so I can't even uncomment this, but that's what it would look like. That's kind of the idea. Okay, so it says this. Let me read this. There are two key points in this implementation. First of all, the interpretation of the primitive operations info and take do not care about any further operations that might come after them. They only perform their single duty, This is similar to how final style monads operate. In fact, the code of info and take is identical to the final style interpretation. The second important point is that we need to convert the done and bind operations explicitly into the corresponding operations of the target monad. Reader T, player, state, this thing. Convert the done and bind operations explicitly into. So it says from our description of operational. Oh, wait, I gotta do another exercise first. Sorry. (1313). Uh-oh. Uh-oh. I liked those before. What's wrong with it now? I don't know what happened. Maybe this is incorrect. Oh? So if we just stick this in here. That's what I wrote, isn't it? Flip that, dot, pure dot. Well, that's the same as flip, right? It just takes them. Is it? You're probably right, but now I'm like confused. How is this different? Okay, that's fine. It's the same, it's just flip bind. Yeah. Hopefully you can read this. If it's too small, let me know. Look at this wild thing. I have no idea what that means. Anyway. Yeah, it's just flip bind, so in theory that should work, but it seems to have a trouble with it. Oh. That's why. I think I need to do it that way. Yep. So I was flipping the wrong operator, arguably. Not arguably, it was the wrong operator. Yeah. And this would be, so why did this one work? No, I don't want to become famous. Ban this person from my chat. If they're in here. I'm getting a ton of these whispers where people are like, do you want to be famous? Son of a gun. This is the same problem, I think. Yeah. Something like this anyway. So this would probably look better if I did what? Either way, I gotta flip. All right, on fmap, you can look as Blackbird on pure. I don't read, so I need to like, I don't read Blackbird as, gosh, this is absurd. Please figure out how to ban these bots. Can I report these people? Yes, I can. Nice. Well, so dumb. Hang on. Sorry. Getting like bots. And it was like, well, tell us the problem. Okay. You give a function that will be composed with pure. You give a function that will be composed with pure. To compose with, you give a function f to compose with pure to compose with this. Okay, I can deal with that. So here, I'm giving a function a to mb to bind and composing that with a dot flip fmap or something. This one's harder to say. This one's a little easier to say. Because you can just say flip return. Or, I'm sorry, flip bind. Anyway. These are a little strange. I gotta work on that. Oh well. Okay, so we're gonna rewrite this fs monad. So that means I just gotta go find it. I'm pretty sure that it was in here. fs. So we're gonna write this as a GADT, I guess. So data FSA where, here, let me do this. Write file Where's the A go? Where does the A go? Oh, I see. I'm gonna have to define a done and bind. That's where the A goes. I get it. Okay, so write file and read file basically don't change. Although I don't know what to do with the M. It seems like I need an M, right? Ugh. Seems like I still need this. I'm not sure. And then we need a done. I'm gonna put an underscore just so I don't have to put two primes. What is a done? Oh, let's do. Okay. What do I do with this A? We need to put it in FS. So this M is actually supposed to be FS, I guess. And then this is going to be FSA, and FS bind will be like this, I guess. All right, so we're attempting to write. Oh, here, I'll get rid of those random highlights. We're attempting to write this monad, which we've already written in, I think, both final style and initial style, and we'll be writing it in operational style now. But my feeling is that this is going to be even easier if we do it with the freer monads as we continue. So, you know, it is what it is. So let me... Okay. So let's open up the final. And what do we want to do? Control T is in a tab. I think we want V is vertical. Yeah. I always forget what those are. I recently realized that they're in it says X or V, X, and T. So I always forget what those keystrokes are because I'm not using them a lot. Okay, so actually maybe I think we need this. Put this here. And then, so we have this FS thing. And, okay. So then we need to... Then we need to write the instances in terms of bind. Except I have bind backwards again. All right, so we're gonna start with this functor fs where. So here's another situation where I need to build a like comparison. Like here is all of these different pieces of code next to one another to see the differences. So I'm going to do that at some point as well. Because I'm pretty sure that I've implemented this FS mock file system thing in every style, but it's not exactly obvious to me which style is which because we keep, you know, we do them too far apart. We'll come back to this. Oh, I think I see what's going on here. So these are the same every time. Oh. Right? If you define the monad, then you actually already have functor and applicative every time. So I think that's probably where this term, I don't know where this term comes from. Okay, and then you can literally copy and paste these because they're exactly the same. They have to be, I think. And then right? And so I guess the idea here is that these are free because you need to, you're going to define some operation on fs bind. Is that the idea? Is that why they're, well, these aren't even free or monads, are they? No. But I suppose what's going to happen is we're going to abstract all this away. We'll see. I don't even really know yet. Okay. So what do we need to do next? We need to write the equivalent of run game. So we're gonna write a function that looks like this one. So we're gonna take it's a natural transformation. We're gonna take a FSA. So this is gonna be like, I don't know, run FS, we'll call it for lack of a better term. It's going to take in a other thing, FSA, and it's going to convert it to what? A state mock file system. And then we need to implement all of these. So there's going to be write file. What's up, Pretz? How are you? So write file. Doing well. That's good to hear. Did you get to write any code today? If yes, what did you write? I think that's going to be my new question for people. I want to know what you guys are working on. It's interesting. Okay. So we're basically writing natural transformations. So we're going to have coroutines on free monads. That's cool. That sounds really fun. But this doesn't... Info. Where'd this go? Oh, okay, here. Why does info take a P? Oh, we're taking a position. I see. Right. So write file is going to take a P and a path and I don't know, contents. And we need to turn this. Yeah, if you have like a gist or something, I'd bring it up on stream. Just don't tell me you're gonna. Just don't send me a private or a DM that tells me, do you want to get rich? I've gotten a lot of those recently. School of Haskell. I've seen that one before. Probably safe to open. Is this you? Or were you just reading about this? That's just a tutorial. Okay, cool. Worth doing? Or should I remove this? Put that up there for now. Okay, so we need to turn this into a state mock file system. So it's gonna be map so wait, no, we can't how do I what? I don't have access to my mock file system, so don't I mean all I can do is insert here, right? I think so. Um I think this is actually confusing me now. Yeah, so I need a return here. Which is what? I have no idea. Is it this? Probably. Uh, I am interested in pipes and conduit. That's one of the things I haven't been able to do, like, work on yet. There's so many things to learn. I'm very much overwhelmed by choice right now. All right, so we need to get the state. And then we need to modify the state. So it's like, it's exactly the same function as I just had, actually. So I should just go get it. This one. Could have matched unit. It's not pure. It's what? Just yeah, I think so too. Um Aren't we working in the state monad? What? Oh, this doesn't return. Do I just void? Still confused. Control V. So this is either oh, right. Let's read modify. Transformers. So it needs a state-to-state function. Your last line should have the type. Yeah, exactly. The last line. Right. That's the problem. So if I stick an A here, this is okay. Thank you. Sorry. I didn't read the error message. I just assumed what I was doing was wrong. I'm apparently tired. I'm doing my best today. Okay, I don't need this after all. So what do I need S for? I don't need S, so I can just modify and then we need to return something, but it's really just this, right? Okay. And this is the same as the right fmap thing. So it should just be this, I think. Yeah. So it's the same as it was before. That's the point. I don't think so. Although maybe you're right. Not sure. Like this, so this IO error isn't real, right? Because I'm just writing to a map. But we should look at that function because I think that, yeah, right. We're not really operating in IO, right? So I'm not, if I was operating in IO, yes, I would need that. And that makes sense because, you know, IO can fail, but I'm doing like a pure thing here. That's not correct. This operation here is pure. There's no like writing to the file system. Yeah. The modify itself is pure. Technically, I'm modifying the state, but the state is just a map. But yes. Okay. Yeah, like there's no way to get a left, really. Okay, so then we would write run fs read file. Here we can fail, right? Because it might not exist. So we're going to read from a path. And so we need to get and then we need to say case m dot lookup. Can map lookup fail? It returns a, yeah, it returns a maybe. Good. So map lookup. Yep, great. I just beat you, I bet, to that because of the stream delay. Well, I guess you beat me no matter what because stream delay. But anyway. Path. It's not result, right? It's like the mock file system. We're going to look up path in the mock file system of just result is a right result. Nothing is a left. And we have to raise an IO error, and I don't remember exactly how to do that. Something like this. Oh, it's probably the other way. Would be my guess. New type, yep. I'm not on my game today. Not at all. Thank you for helping me. Okay, and then we'll just wrap this whole thing in a pure because the pure piece is the same. The only thing that changes is whether it's right or left. I guess not. What's the type here? Let's do this. Hole-driven development, folks. That's just a string. Yes. So this whole wrong thing needs to be isn't that a pure right? Wait, what do we don't do anything with the result? I don't understand. All I can return here is a right unit. Doesn't do anything. Ay ay ay. I have to return a string, like to do anything with read file. Yeah. Okay, so I'm not like I wasn't crazy. So like the only way this works is if I make this a string. And then we need to do the following. We need to modify, we need to get, and we need to we don't need to get. Right? Like that's the only logical thing to do, yeah? Is return what we inserted. Because it's the only string. I can't do anything else. It has to be that. There's no other option. And I need to figure out what the other thing is. Final. User error. We'll just copy this whole. I don't know why I'm not opening these up in tabs. Just useless today, folks. I'm useless. And then we can just stick pure here. Okay. That has to be what we're looking for here, I think. If anyone can see any reason for that not being the case, let me know. We could import or implement functor on git mock file system. We want to do. That would make that a little simpler, but I don't think that's important. All right, so then we need to implement the other things. So you have to implement fs done. Oh, right. Again, I would have to, yeah, you're right. Hey. What is wrong with me today? Um, just an A. How do I indicate this being done? Oh, it's just uh stay T map dot empty. Oh, and then identity. There's no constructor for state. Uh, is the code for FS which part? All of this, or this stuff? Basically the top stuff or the bottom stuff. I'm like a useless coder today. The So this here is the exercise. So the exercise for this section is rewrite this FS in operational style. And so like let me see if I can even find the initial implementation, because I can explain where at least that came from. Yeah, it wasn't really defined in the book. It was basically just here's the different types. And then you implemented all of these things in different styles, essentially. Yeah. So they're just using it as an example. And also, this clearly needs to be a string, I suppose. How do I construct a state? Because this is not a data constructor. It takes an S, I see. But this can't work. Oh, but I need a... I don't know. Oh, right, right. But like, X is nothing. This isn't anything. What is... I mean, what is this supposed to be? I don't think so. I suppose it's just get. Uh, not get. It's the one that returns... It's exec... We don't want the state, we want the A. So it's a val state T. Thank you, by the way. I'm like, I'm completely useless right now. It's a val state T on map empty. It's not. Why am I having such a hard time? This is not right. I mean, I know it's not right, but I feel like I need to just not stream today, but I really want to keep going. But my brain is clearly useless. This requires the whole thing, so I need to do something. I need to do a get. No, I can't do a get. I need an A. I don't have this. I don't know what I put here. Yeah, I don't understand what I'm supposed to put here. I really don't. I'm so confused. Is it done? Maybe. What should it be, though? A string, I guess? No, it can't. Right, it can't be fixed. There, I guess. Maybe it can be fixed here. Either... Maybe this is supposed to be fixed. And then that way I have an X. So I can, right? I guess I don't see how I can do this without an S. I'm sorry, an A. Right? Because this will just be state. Something like this, I guess. No. It's not a dot, it's just state that. Yeah, that's kind of what I was thinking too. Why is this pattern match is redundant? Pattern match is redundant. What does that mean? Case split. Whatever. Okay, so the type of F oh, that's not what I wanted to do. Son of a gun. I'm sorry. That's not right. This is right. Yeah, here's the initial style version. Yeah, so we've written this as a bunch of different things. In like a bunch of different versions. And the code that I'm currently writing is not in the book, by the way. This is my own code written as a solution to this problem. So yeah. Well, it has to be, right? Like this has to be free. But I think it needs to be specialized here. Otherwise, I don't see how you deal with done. Right? Like if this isn't fixed to string, I don't see how you write this. I have no idea if this is correct. I have none whatsoever. So we need to get an A. Is this even allowed? No, of course not. So if we have a FSA. I need run FS. Something like this, I suppose. Again, this is going to be generic. I'm so confused. That A isn't even specific. How do I deal with that? If I put an A here, then I can't write this for sure. And I don't know what that's supposed to be. I don't think that's gonna work, but I mean, I'm willing to try anything at this point. Maybe this is like one of those... No, I don't think this is possible. Because this is specific to a string. If we made this A, then bind would work. Is this supposed to be A? It can't be A. Like, how do I... We can't conjure up an A. We don't... I don't know how to do this. This doesn't make any sense to me. Because I think my data... I think this class is incorrect. What is this called? You mean the... I mean, I don't know. Operational style, yeah. I mean, is there anything in here about... There's nothing in here about operational. I don't know what's gonna... Like, what goes here. It's gotta be a string, I feel like. Because that's the only way read file works. Like, why would you read a file and then throw away the value? Oh. But if this is the case, then how the hell do you implement these things? Seems like you need the same type in all of your constructors. Yeah, let's look at this a little bit more. So these P's are positions, and you're embedding something back in. Is that what I'm doing? Yes. I'm embedding a result back into FS. P So we need an A here. Oh, this return type probably can't be. It's probably got to be A, I guess. Does all this code compile? It does. That's probably the problem. Yeah. Yeah. So they need to be free. The return type has to be free. Now, what goes here though? Just pure X? Oh my goodness. Why does this compile? I mean, what's the type of pure here, I guess? This takes... So, in this X is just an A, but it doesn't have a choice, right? That's the part that's confusing to me, is that this type is an either. Do you see what I mean? Yes, I can. Thank you. And then this can just be... Thank you, Oren. So this A can be different every time? I don't like this style. Yeah. But like, it can only ever be... I guess it can be whatever it wants to be. It only has to be something if I'm using write file because of the return type. I get it. These don't care. These don't care. They're polymorphic in their return types. This one, however, is not polymorphic in its return type. So if I tried to return, like, I don't know, pure unit or something, it wouldn't work. But it has to return an FS of something. Well, okay. It has to bind, like, A has to be this. It doesn't have a choice. That's the point. Interesting. Okay, I think I'm okay now. It definitely feels a little weird. Yeah. So like for these two cases, our types are fixed because, or our return type is fixed because it has to be that way, right? The inside type, as we're referring to it, has to be either IO, error, unit. That's the only option for A. So you're like restricting the return type in the write file and read file case, but in the fs done and fs bind case, you leave them polymorphic. And the implementations for these things are always the same. So everything here is essentially, well, that's not true. Everything here is essentially all boilerplate. Yeah, and you start with a GADT, that's correct. So like the fs done or done and bind are boilerplate. They have to be this way, like where you just take the monad and you stick it here. The functor instance is always the same. Applicative is the same. Monad is the same. Assuming this was just bind, whatever. And then these instances are the same. The only two you have to write are write file and read file, and they have to return whatever type is in here as the inside type. I think that's what we're going to get to next, by the way. The freer monad. Okay. We got there. It was a little harder than I was hoping, but we got there. Okay, so it is 9:40, and I usually take a little break right around 9. You define your non-boilerplate functor, and free provides the boilerplate constructors and instances. I think that's what we're going to do next. So let me flip the page. Yeah, so there's the next section is called operational monads as free monads. So they're going to give us a little motivation for how free monads work, I guess, and then we have another exercise, and then we get to that section called operational monads as free monads. But I'm going to take a super quick break before we do that and grab some more water and use the bathroom. So give me just a few minutes, and we'll be right back. Feel free to, talk among yourselves, meet each other, say hi, those sorts of things. Okay. Oh, I forgot my glasses. Okay. And I almost hit stop streaming again. Gotta be careful about that. I just want to switch here. Okay. So I feel a little bit better about this, but it was pretty strange to me. So what I want to do, we're not using that anymore. We must be using this. Maybe we aren't. So here's what we'll do. We'll move source lib to source operational style. Okay. And somewhere in here I have lib, so this needs to be operational style. I think that's gonna be the only problem. Yeah. But let's move this stuff back into lib. I don't know what we're gonna need, so let's just start from scratch. What is happening? Lib. Let's move this here. We'll leave that there. Okay, so are we using random RIO here? I didn't think so. We're using void. No. We're certainly not using Clydesley arrow. We're not using this. We are using these and this. Are we using lift? I don't think so. We're not using that. I think we're using both state and reader. So this should be good. Yep. Okay. So let's close that. And let's go down here. And we're gonna start. We did that. We did that. Okay. So from our description of operational style monads, there's clearly room for abstraction. All of them introduce constructors similar to done and bind. Following the lead of initial style, the similarities of which can be abstracted into free monads, we can also abstract the commonalities of operational style into the so-called freer monad. All right, so initial style, free monad, operational style, freer monad. That's the relationship. I'm gonna write that here. So initial style to free monad. Initial style there. Operational style. So I think what we should do at some point is, well, we need to do some Googling around, but we should write a tutorial where people just implement that FS monad in a bunch of different styles, but don't tell them what they're doing. Like just say, implement these things. And then at the end of it, say, okay, this was implemented in what's called initial style. And notice how the boilerplate was removed from blah, blah, blah. That's now a free monad, and just move on like that. That could be an interesting post. like don't explain all these styles. Like just have them implement some code and then tell them what it is. Could be fun. Okay, so as in the case with free monads, the custom part of each freer monad is described in its own data type. But in contrast to free monads, we do not have to introduce any type variables or change the data type in any way. The constructors look exactly as they did for operational style monad, which in turn means that they take the type of the primitive operations. Haskellers tend to say that this data type describes the instructions. Okay. So we're going to write another GADT, I suppose. Yeah, so maybe these are written slightly differently, but like these might not be the exact core types that are there, but they describe this as initial style monads. And I think that's because there's a done, a bind, and a pure. And like stylistically, that's how they're made. Oh, that is the actual type. Yeah, they call that initial style in the book. That might be not exactly correct. It may be like it's actually free. It's actually a free monad, but you know, we're going to describe it as an initial style monad for now. Something like that. I have no idea. Or I misinterpreted what they were saying, which is also entirely possible. So we're going to write data, tick, tack, toe, I. So the I here stands for, so I for instructions. We're gonna have to go get those data types again. Ecto I, maybe player. Take. Okay, so F. These things. We might need board, I don't even know. Okay, so we're gonna need language. GDT. We're gonna need import qualified data map as map import data map. Yeah, to make that work, I don't know if we're gonna need those later, but we'll do that. Okay, the freer monad just embeds those constructors into a common data type for the return and bind operation. So we're gonna say data program instructions a where done. Why is this backwards? I mean, it doesn't matter, obviously, but it's kind of funny. Let's change this one because I don't care about it anymore. I'm not entirely sure why these are switched. So like my you know, my brain is like, why is B before A? So I need to fix that because I'm gonna lose my mind. Okay, so now what? Write the monad instance for program inster. Please note that this instance does not depend on which set of instructions you work on. Hint, as in the case of operational style monad, this instance is obtained by using some of the constructors in program inster. So instance monad program inster where return who's this? Oh, right. I gotta fill in the holes. We're probably not gonna need that. Really should write a like a macro to do this for me. Not a macro and a you don't need this. Okay, so start down here. It's the other way. Weird. The formatter removes the space there? How strange. Why? I hate that. Sorry. Okay. I don't know why I clicked the formatter, but I did. I meant to hit the D, comma C, D. So we need an A? I mean, it's just bind, isn't it? And pure should just be done. Think. Okay. There's a bunch of talk about Scala. I'm still confused at how I've saved myself time. Please explain. I've not reduced boilerplate. Have I? What what time have I saved? I don't understand. Oh, I get it. Because all I have to do is this program thing. If I have this, then all I need to do is wrap my data type with this thing. That's why. Okay, I get it. Sorry. All I need to define is my data type, and I get a free monad from it. Okay, I get it. So the program data type allows us to write the instructions and get a tree or okay, interesting. I think I'm gonna get a lot of insight by putting these things next to one another. For a long time, I thought Freer was someone's name, by the way. Okay, so, cool. So, you know, let's just put neat. So let's go down here and write okay, so there's they show us the Scala version, which is a little bit different apparently. Um, in there's a step function. I don't know. It's Scala. It doesn't mean anything to me really. So basically, we're gonna rewrite program as freer. Wrong with this? Ah, right. feel like I'm missing something now. Hang on. Huh. This is kind of interesting. I'm confused why we haven't seen this before, but we'll see in a second, I suppose. Apparently. Well, we haven't gotten that far, so hang on. I don't know. That's what it says though. It says operational monads is free monads. And then there's some talk about ko-yoneda in a second, so I'll be honest, I don't know what's gonna happen here. Okay. So we don't need to define return. X K F functor. Yeah. I think the point is that you can just derive them. This is pure prime, and this should be able to be imported from 4. Yeah, I think the idea is just that, like, look, these are, you can do the same sort of things between these. They are functionally the same thing, and there's conversions between the two. Probably that's probably the point. It's probably more from a theoretical standpoint than anything. Okay, what's K here? Okay. And F finds a monad. So we have two functions that, two monadic looking functions. So you can Kleisli them. Okay, cool. Now it says, write the functor and applicative instances. So I don't think these are actually the same as before. Otherwise, we probably wouldn't be implementing them. All right, so F is just an A to B, and this is a freer insta A. Pickass, do you have Chris Penner's Lens book on your list? Yep, that's the next one. So when we finish Book of Monads, that's what we're going to do on Tuesdays, the lens book. Because I'm very interested in learning about lenses. I see people using them all the time, and it bothers me that I don't know how to do it. Great. Yeah, so you'll be able to help me. Pure X, and then impure XK, I guess. I see. Yeah, like I've used lenses, but as a very naive, like, oh, the types line up, so I guess this is correct. And like I see the point. I think it was you that mentioned that we could probably use lenses to clean up some of the code we were working on last week, actually. Last weekend. Somebody suggested them anyway. But I'd like to learn about them. And also, I want to know, and I don't know the answer to this, is if code written with arrow, I guess I don't know what to look up. I can look up that GitHub thing that I'm working on. This thing. So this Opal code requires this arrows thing. So where do we use them? Here. So here's an example of using them. So we use these arrows things, and I'm wondering if there's lenses that correspond to these things. I mean, lining up the types is the beauty thing about Haskell, right? Anyway, I'm wondering if you can replace the usage of arrows with lenses in Opal. I don't know, but I think it would be interesting. Maybe there's a like a, I don't know. I have no idea, Prutz. I wish I could answer that. I don't know that either. Pick, do you know? I have no idea. I don't even really know what lenses are for, but I saw the picture of arrows. Yeah, it's basically the same thing. I saw the picture of arrows values in a data type. So, okay, so let me arrows Haskell. So I saw like this kind of picture, and I'm wondering if these kinds of pictures are representable with lenses. I mean, this is a basic one, right, with integers and stuff. But if you had monad, I wonder if there's sort of interesting things that you can do. Again, I'm talking completely hypothetically because I have no idea. Lens. What if we just search for lens? Lens, excuse me. Yeah. I don't know enough about lens, so like I shouldn't pretend like I know what I'm talking about because I don't have a clue. All right, so this is an A, that's an F, so this is going to be a pure FX. This one's easy. This one's harder. So that's an inster A, that's an A2 whatever, that's an A2B. So yeah, I guess the difference here is that you have this monadic thing that happens first. Insert A. That can't be right. Hole-driven development. So that's what I was thinking, but it doesn't work. All right, so what is the type of this? Well, that's not. We need a function. Yeah, so we need an A, right? So we can do something. That gives me A1. Wait, both of these things take A. Right? Both of these things take A. Is that why it's... Is that why it was written that way? Oops. I don't think that changes anything really, though. Oops. I guess it does. Yeah, that's okay. So F dot K. No, K dot F. No. No, this can't work either. This doesn't matter. This doesn't change anything. Ignore the holes, please. That's the only thing I don't like about this is if you put holes here, you see them in GHCID, unfortunately. Right. So if we do it this way, we go from A to B. Yeah, yep. That's why, like, hole-driven development is amazing. Like, just put holes all over your code, and when you run into issues, you can just, like, start adding them in certain places and see if the code will even compile, right? Like, a lot of times what I'll do is I'll be like, do something like this. And I know, just by looking at this, that this is not what I'm supposed to be doing, right? Because it doesn't compile. So there's nothing that fits there to make this work. There's nothing that fits there to make this work. You see what I mean? So it's like you can quickly kind of analyze how this is gonna how this is gonna go. But there's a lot of really cool stuff you can do here. But again, these are literal errors. So if we save this, it's just gonna complain because it can't find a binding that fits there. So that's something that's pretty useful, I think. I feel like maybe I'm on to something here, because this is just a so this has to be a freer instrument A, sorry, B. And the only thing, what's the type here? That's a B. So if I apply K to A, this is the wrong one, because I have A with B. What's X again? Am I supposed to feed X? Like, is an impure supposed to become a pure? That doesn't seem like a thing. I mean, again, you can try it. Like, if you just do this, it doesn't complain. This has to be a B. There's no way I can create a B. Here? Yep. Found hole. That's not what was there, by the way. That was somewhere else. Here? Yeah, so A has to be... I mean, this has to be X, I feel like. Oh, right. I see what you're saying with the functor laws. Let me... Right, so B has to be a function. A to freer I keep saying insta. It's not insta, but I want to say what anyway. So it's like you have to have a function that ignores its input. No. So something is going to make, yeah. Yeah, that's what I'm thinking. It's got to be like A K A like that. So sometimes when I see this, I'm like, wait a second, how is this ever terminating? I guess the idea is eventually, because fmap is applied to a smaller subtree with each call. Smaller subtree. Yeah, that's what I was thinking. Like eventually we have to hit this. That's our termination condition, right? Eventually you have to hit it. Otherwise, yeah, you're right. The value will never. Okay. Yeah. I'm really having a hard time today, I think. Some days are better than others, that's for sure. Okay, so yeah, that's an embedded function. And this is the one. Wait, these are both freer, aren't they? So this is going to be, we're going to have a few of these. Pure prime f, pure prime x. And then we have to have this one. Let's just write this and look at what these things are. Keep doing the wrong thing. So that's an A to B. That's an A. Easy. Right, that's the termination, right? So these things are going to be recursive. They have to be recursive. Because eventually they have to reach this. So we have to, that's the idea, is you have to use apply inside the definition, I guess. Now, let's see if the types even work out here. They have to. We have an A to B here. So the result of this has to be impure x something. And it's going to be like, right, so this is an A, and this takes an A as well. Right, because it's going to be probably something like, So that would get rid of this one. And it's probably... By the way, it is a common trick if you already have monad. You can do applicative with... Oh. Really? How? Isn't that only true before this happened? Because didn't uh C note recursive bindings for applicative monad. Note. What is happening right now? Control F. Can't control F in here? Okay. If I just look up... Yeah, that's what I was gonna do. What's going on? Am I still here? Not dropping any frames? Seems like my internet's okay. Why don't you... That back really screwed that up. Oh, so this is just defining control monad. Okay. I suppose that's probably what they would do, but let's see if we can just finish this. So this is going to be impure x mean the source code comment. Code comment. I don't understand. Sorry. Since many applicative instances define app, we cannot define app equals. Oh, was that in the documentation I was looking at that I didn't read very carefully? Okay, I mean that's interesting. I guess I've never used the app function, so sorry, I forgot what I was doing here. So this is gonna take on A and convert it to the function. and this is an A. How does this ever work? That can't compile. Because this gives you a function. I'm confused at what you're trying to tell me. I'm sorry. How does this ever work? Can it? Maybe it can't. How do I recursively apply here? Maybe the idea is I need to give this an A and then apply. I don't think this will work because this has got to be like a. What's up, Sky Bro? How are you? So I need it. How do I get the A1? This is an A. This is an A1 to B. $5 a.m. Okay. You came to watch me? That's a weird thing to do. I appreciate it. I don't think I would want to do that that early, though. I don't see how I deal with this. So I have. Let's write some stuff down. So I have x prime, which is an A. I have k, which is an A to impure. I mean, that's fine. I'm not really judging you. Just saying. Okay, so k is this thing. And A is what? Just an A. So now I have two A's again. But I don't have an F. Like, here I had something to apply with. Maybe I just ignore? Can't possibly do that. Maybe this is just KA. No, not KA, X prime. This is a... Do I apply to pure A? Interesting. How does this one terminate? I guess it's the same idea, right? We're just reducing this one until we get to a pure. We found a pure on the right side. So like this one is being reduced until we find a pure on the right side, and then we find a pure on the left side. Sorry. Yeah. I have no idea if this is correct. But I guess we would need to find a pure here first. So this makes sense. And then once we find a... That's why that one's above, I guess? I don't know. Then once we find a pure there, then we just need to find a pure on this side. And then eventually we hit this. So this pure x prime can clearly just be... I don't know. That's kind of fun looking. Okay, so this was actually exercise 13.15. Implement functor applicative. I'm starting to see like the recursive nature of what's going on here. I'm not sure I fully understand the purpose still. Like, when do I do this? When do I want this? That part is still very unclear to me. But I'm hoping that's gonna come. Can I ask you guys a question before we leave? So it's 10, I usually stop at 10:30. It's 10:45. So, yeah, like, yes, but I'm trying to figure out like, when do I want that? You know what I mean? Like, I guess with a game, it makes sense because there's like a step happening recursively until we're done. Or in something like, I don't know, like a web server, like we want to continue doing something over and over again until we're done. Something like that, I guess. So it's like, basically everything is this way in real life. Games, websites, streaming data, that is. I get it. Okay. Wow. I feel like my mind is finally opening up to this. Maybe. Very slowly, anyway. Okay. Neat. I need to think about this more, but I feel like I'm getting... So maybe the problem is that I don't fully comprehend like really what a DSL is. I think I'm starting to, but you know, it's just, this isn't stuff that I do every day. But I think there's people who do this kind of stuff every day that immediately realize how this is useful. Is that like it? Does that sound reasonable? And for me, because I write kind of more sciencey, non DSL type code, that it just doesn't seem obvious where I would use this. I hope that is kind of in response to what I'm talking about. Like, is this obvious why this is useful? I think that's the like if you write everything in IO. Anyway, I'm gonna sit on this a little bit longer.